I live in Kyiv, and I'm software engineer and data analyst in Texty. Texty or UA is independent media. We create data journalism project and work in traditional journalism genres. We have Ukrainian view of world. We try to study the problem we're writing about as much as possible and to show what is really happening, not simply publishing different points of view. And today I want to talk about satellite images and how they can be explored for information. It will about SAR satellite imagery and information mining from this dataset. Plan for this presentation is SAR imagery overview. I tell about how SAR satellites works, where I find data and how processing it, and some practical examples of use SAR imagery. And so we begin. I think we have all seen pictures of Maxar published by almost all the media. We have a column of Russian troops, 64 maybe kilometers long, moved to Kyiv from the Chernobyl zone. This is example of optical satellite imagery. They are probably the most popular and very easy to understand for all users. With them, you can get a lot of information, but the problem is that they are very few and they are expensive in good resolution. The main reason is cloudiness and night. These satellites work by receiving the sun's rays and transforming them into images. In fact, it's like camera in space. There are satellites that can bypass these restrictions and work even in 100% clouds and or at night. So synthetic aperture radar, or SAR, is an active system operating in microwave domain of this electromagnetic spectrum. Microwaves are not visible to the human eye and provide a very different view of the world from what we are used to. While optical remote sensing sensors function similar to the human eye, they are passive sensor which record reflected sunlight. A radar sensor operates more like a flash camera in a dark room. The radar emits a light pulse and records a part of the pulse that is reflected or scattered back to the sensor. Unlike sunlight, which is not polarized and comprises a large range of different wavelengths, the radar is a laser which operates within narrow and well-defined wavelengths bands and a specific polarization. So in order to correctly interpret the content of the SAR image, some basic understanding how radar signal interact with different link cover types is required. So this is a short description of some of the most important backscatter mechanism. First is direct scattering, for occurs when the transmitted signal is reflected directly back to the sensor by single reflection. It's something like for rock or mountain slopes oriented towards the radar. Next is forward scattering, a smooth surface such as calm water surface or bare soil. And the signal reflects once on the surface and continues its path away from the SAR antenna. Diffuse scattering is around surface, such as plugged field or waves on water, results in the signal being scattered in different directions. And other types of scattering mechanism. So different radar signal scattering, we can detect different objects. For example, a ship at sea is well detected in the sea because it reflects the signal in different ways. So we understand what are satellite image and how they work. In fact, it's just a radar that constantly scans the Earth with waves of a given range. If we move on to the practical application, the data from Sentinel-1 program is almost the only one free option for us. And Sentinel-1 is a mission composed of constellation of two satellites, Sentinel-1A and Sentinel-1B, which provide a 12-day repeat cycle for one satellite and 6-day repeat for two satellites. And some ground location can be covered at even higher frequency. For example, is for Europe. You can use such service to get images. SkyHub by Copernicus is an official resource where you can get raw images and use them for any purpose. Also, Sentinel Hub or Landover. If you want to get an accessibility image and using the default settings as soon as possible, in my opinion, these services are best used for preliminary analysis and quick search of images. And Earth Engine by Google, for me personally, this is the most amazing tool for processing satellite images. It allows you to automatically process hundreds of images per second on Google servers, then download the result and continue processing in any programming languages. This saves a lot of resources and quickly get the results. If you want to do programmable image processing, download the results and final process the results using any programming languages. For example, here is an example dashboard. So what this dashboard looks like in Earth Engine. It's a simple demo example from Google. Here we type any code what you want. So filter any date, choose any data sets. This is Copernicus Sentinel-1, and make something great. Here is Netherlands, and we can easily find, for example, turbine near Netherlands, and maybe detect them and use for projects you want. Here you can also process other available datasets like Landsat-8, Sentinel-2, or others. The public data archive includes more than 30 years of historical imagery and scientific datasets, updated and expanded daily. It contains over 40 petabytes of geospatial data instantly available for analysis. And you can combine different datasets to achieve your goals. The programming languages here is JavaScript. There is also an SDK for using Python. For example, you can use Google Colab for your searches. Tell about some projects. What we do with Sentinel-1. First is monitoring of Russian bases on the eve of the war. I developed this project with Anatoly Bondarenko and Evgenia Drozdova. And history, sometime in the early fall of 21 year, when a new wave of leaks began about Russians' plan for war in Ukraine, we began to think about how to visualize an accumulation of troops near the border with Ukraine and somehow monitor it. We came to the conclusion that the best solution is to do a time series at every known point. The satellite images used are made by radar sensor and so do not depend on weather and time of the day. Sentinel-Y satellites surveys the terrain at least one every 6 days for Europe. And for example, consider the base in Illia Samoilych region, for which detailed satellite photos from November 2021 and compare them with image in our visualization. The satellite image from Maxar, brown rotated in center, show line up rows or armored units, a large military vehicles. The white lines show the boundaries of site field with equipment. You can also see this picture detail in our article by link. Okay. On the right, on Sentinel-1 radar, all this equipment inside the white outlines looks like cluster of color pixels, bristles and background. For comparison, here is another picture from Sentinel-1, but taken more than a year ago. You can see that the machinery is not there. So when we view screen from our interactive map, you need to pay attention to accumulation of similar pixels of purple, green, or even less white inside white outlines of the bases. Well, you can see that before February 24, the troops began to leave their bases. This were first sign that something was beginning. The list of military bases we took from OSINT research and various media. We verify them from optical images like Sentinel-2 or PlanetScope satellites. The only one nuance is what this methodology do not guarantee 100% reliability of the data, because if you really want, you can mute the radar signal and we will see just a spot in the image. Now we also monitoring in similar way how Russia is removing armored vehicle from the reservation, because I think it's not secret how many losses are in the Russian troops. And we are researching where they get this technique and how quickly they use their supplies. Next, our article research about military radar. Something unexpected. We found military radar using algorithm described on Medium by research Harold Dan. The author of this article noticed that if you aggregate pictures in a few days, you can see obstacles in form of dense purple rectangles or cursor in the picture. He tried to investigate what was going on in this area where such crosses appeared, and he found American Patriot anti-aircraft system. Their radars are so powerful that they create noise for satellites. It is the noise that we can see in this picture, here and here. Russian air defense system use similar radars, so in theory we can also see them in satellite images. But that rectangle seen in the pictures is not the range of the radar, but a sign of its work. If you interested in understanding in more details how this approach works, read initial article link below. Looking at the territory north of the city in Izium, we found traces of two positions of military Russian radars. One of them hides a very important river crossing, the other a military base in Veluiki on the border with Ukraine. Both radars have already worked in the active phase of the war. Another case of use Sentinel-1 images may be finding war damage building. For example, economist for Mariupol did this, and based on this, develop map of damage in this city. This is possible because the radar is reflected in different ways from smooth surface, such a roof, and from destroyed house. And if you take the image before and during the war, they highlight the difference. You can identify buildings that were damaged. And finally, I also want to show how ship look on Sentinel-1. Because ships are metallical and smooth, you can very easily highlight it at sea. And quite simple steps to find out where on which day the ships were and how they were. If you are interested in this topic, you can conduct your own analysis and explore. For example, in Black Sea, you can even find flagship Moscow and find where it was flooded. My presentation is over. I hope you found it interesting and useful.